Next, we have Chihua Tsai, who is an international student from Taiwan. She received a bachelor's degree in international business and has since worked as a salesperson for a trading company specializing in automobile components, electronics, and more. Currently, Chihua is pursuing her master's degree in telecommunications at George Mason University, after which she plans to work in the US and may eventually go back to Taiwan to contribute to Taiwan's development in the field of telecommunications. Chihua Tsai.
Good morning, everyone. Today I'm going to talk about the future perspectives of energy efficiency wellness communications. At the same time, I will introduce some future study topics. Within 2 decades, the weather has become so unpredictable. According to international panel on climate change, the majority of greenhouse gas is caused by human activities. Therefore, the importance of reducing CO2 emission has been addressed, and this has become a critical and urgent issue to solve. From this chart, you can see that CO2 emission from wireless communications has been increasing from 2002 and 2020. It increased almost twice than in what it was in 2002. Because of this, more and more attention has been paid to reduce energy consumption in telecommunication industry, especially in wireless communications. So many techniques of reducing power consumption have been discussed. For the summary part I will read in Chinese, I would like to invite everyone to follow along with me by reading the English summary. 在所有的领域及各行各业中，减少能源消耗是一个重要的课题。它不仅可以减缓全球暖化的影响，更可使各产业减少开支。在无线通讯磁产业更适合利用。因此，在此学术的分析谈论中，将会阐述部分其能源的方法，并提出未来的做法。In this presentation, I'll briefly introduce some techniques which are commonly discussed in wireless communications. Secondly, I will talk about some changes of implementing energy efficiency techniques. Finally, I will talk about some future possible study topics and discuss the question of theoretical solution and real-world applications. Since the importance of saving energy has been addressed, nowadays scholars, experts, and professionals are working on developing new techniques to reduce power consumption during data transmission. In addition, many current technologies of energy efficiency have been discussed in wireless communication. For example, wind, radio, earth, sensor map, time-out map, and more. In this research talk, I will introduce 2 technologies currently discussed. One is OFDMA, the other one is MI. Among so many energy efficiency techniques, the first one I would like to introduce is OFDMA. OFDMA is called orthogonal frequency division multiple access, which is one of the energy efficiency channel access schemes. From this slide, you can see there are more than 3 techniques under the channel access schemes, and OFDMA is one of them. In OFDMA, in order to achieve high performance, system resources such as sub-carriers and transmit power needs to be properly allocated to the different users. And in this scheme, the first goal is addressing the circuit's consumption. When you design the circuits, you have to try to reduce the energy. Second, maximize the energy efficiency by adjusting both total transmit power and its distribution amongst sub-carriers. And then it will reach the final goal, reduce at least 15% of overall energy consumption when frequency diversity is exported. And the next technologies I want to introduce is MIMO, which is multiple input, multiple output, which is under so many channel access schemes. MIMO is one of the techniques to reduce the power consumption. In the MIMO is classified by the number of users. For example, SISO is single input, single output, and SIMO is single input, multiple output. However, MIMO can also be used with a single user or multiple users. From this figure, you can see the function of the MIMO is clear explained. I would like to use another simple example to further explain this. If you are the only one person to use internet, that you can refer as the SISO, the first one in this chart. In this scheme, some advantages have been discovered. First of all, reliability and capacity will be improved. For example, in downlink of 3G TP-LTE, both Su-MIMO and Mu-MIMO are supported. This proves that different modes can be selected due to the spatial specific requirements. Furthermore, by applying this scheme, the throughput of cell H users and coverage will be improved as well. However, although the reliability and capacity is improved, we still figure out some disadvantages when we are implementing this scheme. For example, more circuit energy is consumed because of the duplication of transmission and receiving antennas. The energy efficiency of multiple antenna system might be lower than a single antenna system. Furthermore, more time or frequency resources are spent during transmission. For example, if most MIMO schemes, channel states information is required at both the transmitter and receiver in order to get good performance. Increasing the number of channels and antennas results in more overhead in MIMO schemes. MIMO is just one of the processes during the data transmission. In order to increase the energy efficiency, sometimes we will make another process that's efficient. This is what we should study more in the future. Among these two techniques I introduced before, some limitations have been discovered. In OFDMA nowadays is mainly focused on uplink transmission. Energy efficiency in uplink transmission theoretically increase when users move towers to base station, which means if the user are closer to the base stations, the higher modulation will be issued. However, there's no guarantee of improving energy efficiency. It's more important to note that the trade-off between spatial efficiency and energy efficiency always improves spatial efficiency. Since nowadays all FDMA currents focus on uplink transmission, for this future focus should be emphasized on downlink transmission and base station for the green design targets. And in MIMO scheme, nowadays mainly focus on the open loop schemes, which only improve spectral efficiency. Overhead of these schemes also consume additional sources, for example, time, bandwidth, and power. So, in these techniques, future topics of studies could be closed loop MIMO scheme, or energy efficiency MIMO OFDMA scheme. As we know, most of the MIMO schemes are incorporated into OFDMA schemes. The spatial and frequency resources can jointly allocated to improve the energy efficiency. However, this might cause another issue that should be studied. It is also important to find a balance between the energy efficiency parts of the process and make sure the whole entire process is energy efficiency. Nowadays, the industry is currently finding the process are efficient in theory, but it's not efficient in real world. Due to these factors not considered in real world, in the future we should focus on more practical applications. For example, OFDMA should reduce energy consumption up to 50%, but it doesn't show that currently. In conclusion, in this research talk, I introduced some techniques which have been developed to improve the system efficiency, such as OFDMA and MIMO. However, according to the study, increasing the system efficiency might require more power instead of reduce the energy consumption during transmission. Furthermore, little attention has been paid to show the results combining theories and practical performances. As a result, more research about how to make the techniques more practical and implementable.